In March 2024, a Microsoft developer named Andres Freund was running a series of routine software tests. This graph shows exactly what caught his eye: a flat baseline CPU load that suddenly registered a sharp, unexplained spike. It caused a lag of 500 milliseconds, just half a second, when Andres tried to log into a machine using a secure remote access tool. To almost anyone else, it's a tiny, ignorable glitch, but Andres decided to investigate, and what he found was a sophisticated, intentionally planted backdoor hidden deep within the code. If this code had been fully deployed, it would have granted hackers silent, remote access to physical servers all over the planet. The compromised servers include those powering hospitals, the world's top 500 supercomputers, and even the internal networks of the United States government. Andres didn't know it yet, but his curiosity about that half-second delay was the only thing standing between the current digital status quo and a coordinated global takeover of our most sensitive infrastructure. To understand how a plot this massive even begins, we have to look at the internet's hidden architecture: open source. This is a collaborative model, similar to Wikipedia, where the source code is public and anyone can suggest improvements or changes. The backbone of this model is Linux. It's an open source operating system that powers nearly every server, mainframe, and supercomputer on Earth. This diagram illustrates the problem. This tiny foundational block at the very bottom represents a tool called Utils. It's a specific utility used to compress data, and because it's so efficient, it's baked directly into almost every major version of Linux. Because Utils is essential for the system to function, compromising that one small block effectively compromises the entire towering stack of global networks built on top of it. It's a terrifying reality. The multi-trillion-dollar digital economy is sitting on a fragile foundation of free code, maintained by a small group of overworked, unpaid volunteers. One of those volunteers is Lasse Collin. Since 2005, he has maintained Utils in his spare time, reviewing every single line of code as an unpaid hobby. By 2021, Collin was struggling. He was open about his burnout and mental health struggles, admitting his ability to care for the project was becoming limited by his massive workload. Suddenly, anonymous accounts like Jigar Kumar and Dennis began a campaign of harassment. They flooded Collin's inbox, demanding faster updates and pressuring him to step aside for a new maintainer who actually had time for the job. In the middle of this pressure, a new user named Jia Tan appeared. Jia was the perfect contrast: polite, dedicated, and eager to help Collin lighten the load. Jia Tan spent 2 full years building trust. They contributed perfectly clean, helpful code to several other open source projects before ever suggesting a change to Utils. This was a highly coordinated social engineering heist, one that relied on psychological manipulation of a single person rather than just a technical brute force attack. Having finally earned co-maintainer status, Jia Tan's first move was to quietly change the security routing for the project, ensuring Lasse Collin would no longer receive vulnerability alerts. With the primary gatekeeper sidelined, Jia Tan slipped the malicious backdoor code into the official Utils update. Investigators found a clear digital fingerprint. This scatterplot of Jia's code commits reveals a standard 9 to 5 Eastern European workday. The biggest clue? The account went completely silent during major Russian national holidays. This level of patience and sophistication is the hallmark of APT29, also known as Cozy Bear, a Russian state-sponsored hacker group. The trap was set. The hackers had successfully gained administrative control, and the infected code was already being integrated into a test version of the Debian operating system. This brings us back to Andres Freund. Because the backdoor was so well disguised, the code itself became slightly heavy to execute. That extra weight is the only reason Andres noticed that 500 millisecond lag at the very beginning of this story. Andres went public with his findings, triggering an emergency alert from the US Cyber Defense Agency. Global developers were able to successfully neutralize the backdoor just days before it was scheduled for mass deployment. The internet dodged a bullet by pure dumb luck. But we've received a chilling wake-up call. Hostile states now know that the most effective way to conquer global digital infrastructure is to exploit the unpaid, invisible humans holding it together.